All right, so we're going to talk about how a circle relates to trigonometry. So what we want to do is take a look at all of these different coordinates that we have sitting on the outside of a circle, and we need to relate that to trigonometry. So trigonometry is all about an angle and ratios of side lengths. So on this first example here, if you had a radius going from the center of the circle, which is the origin in this case, 0, 0, and we draw it out to that point right here, we are in the first quadrant, positive x, positive y. And so how do you relate these coordinates to the x and y coordinate system down there below it? This is the x length right here, going from here to here. And this is the y length right here, right? There's your y over here, there's your x over here. So this is the x and this is the y. And this is the radius of the circle. Here is your angle right here from the positive x-axis to that radius right there. So here we are in the second quadrant over here, the point on your circle. So we've had a radius sweeping around your circle and it stops right here. This is your angle. It starts at the positive x-axis and goes and it stops right here where that radius is. It tells you this is what your angle is. Now, how do you determine that x and y? Here, I hope you see there is another triangle here. This is your negative x distance and your positive y right here. These are all right triangles, by the way, and so now you start to see that there is some connection with trigonometry. There are angles and side lengths of a triangle happening here. Now we are going to look at the third quadrant over here. So you've had an angle sweep all the way around, right? It's turning around. Whatever your theta is tells you when it's going to stop. And there's the radius of your circle right here. So your angle starts at the positive x-axis and it goes all the way around to here. There's your theta. So now you have the same thing going on. You have, this is your, from the x-axis here, right? You look at the coordinate graph here. This is your origin. This is negative x, and this is negative y in that direction. So now we have another triangle being formed here. All right, we're going to put this all together in a little bit. Just make sure you understand this right now. Last one, we have quadrant 4. So your theta is giving you an angle that's going to end up in quadrant 4, sorry. So here's your radius. So your angle was all the way from the positive x-axis, going all the way around until we got to quadrant 4. So that theta is going to be given to you. You just have to know where it ends up. Is it in quadrant 1, 2, 3, or 4? Okay, that's all you have to worry about. Once your radius stops in that quadrant, you draw your triangle. Here's the negative y value. Here's the positive x. See the coordinate system below the circle, okay? Every point, right, has its quadrant that it belongs to. We're just talking about the points around the circle. What quadrant are they in? So there's your positive x and your negative y on that one. So now let's relate all this. Let's put this together. Let's talk about reference angles. So let me find that. I think here it is right here. Okay. So this This is building on the idea of finding a triangle inside that circle there, right? We still have the same, we've got a point here on the edge of the circle. So we have an angle theta, which is given to you. Say this one ends up in your second quadrant here. Here's your theta. So that lets you draw this triangle here, right? From the terminal side of that theta, right? Here's the initial side. That's the green is the terminal side. From the terminal side, we're going to drop that down to the x-axis right here, which creates a right triangle. So on this one, you're going to have a negative x and a positive y. And here's your radius. Now, from this, you can find this angle right here, and I'm going to write it in white so you can see it. This angle right here inside the triangle. Now we have all we need for trigonometry. We're talking about this angle right here. We're going to call it alpha. That's a Greek letter alpha. This is your reference angle. Your reference angle is alpha. Or you could call it something else, but that's what we're going to call it right now, okay? So let's do some examples here to see what we're talking about. Pretty soon we're going to be putting all of these ideas together. So we're going to find these reference angles right here, one after another. So first one here, if they give you a theta of 330 degrees. So let's draw our circle here. I'll make a blue circle now. Now my circles might be a little bit wobbly, sorry. Okay, so which quadrant would 330 fall in? Well, here's my initial side, always starts at 0 degrees. And I'm going to go around in the positive rotation direction. There's 90, right? This is 90. This is 180. This is 270. And then one time all the way around would be 360. So it's going to go all the way around to somewhere here in the fourth quadrant, right? And it's going to end up here in the fourth quadrant. Now you can drop this down, right? If this is 0, 0, this is a negative y right here on that point, right? And the x right here is positive from here to here on the triangle. So you have a positive x and a negative y. Think about it. Any point, this point right here, any point in the fourth quadrant is a positive x and a negative y. This is 0, 0, the center of the circle. So this angle right here, where can I put it, is your reference angle. The reference angle here, what is between 330 degrees, right? This was 330 up to that point. 330 to 360, that leaves you your reference angle of 30 degrees. So what we would look at in trigonometry would be a triangle that looks like this. It's not drawn to scale now. Where this would be 30 degrees, and then you would have an x and a y and a radius right there. Okay, and it's a right triangle, right? This is right here. Okay, let me draw a bigger one for this next one here. So let's draw another for part 2 here. Let's draw a bigger circle if we can. There's your x and your y. It's a little bit bigger. Okay. There's the y, there's the x. This is the origin right here, okay? So 3 pi over 4, this is in radians. So I've got another video talking about radians there. So we've got, this is 0 radians right here. And up here, if you go one time around the circle, that's 2 pi, right? 2 pi is 1 time around the circle. That means halfway around the circle is over here. That would be pi. And then halfway between 0 and pi, a quarter way around the circle, that would be pi over 2. And then halfway between pi over 2 and 0, 0 and pi over 2, that's a quarter way around the circle, so that's pi over 4. So here would be 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4, which is same as pi, right? 4 over 4 equals 1. So here is where 3 pi over 4 is, right there. So this is your angle, theta, goes all the way to here. Initial side, terminal side, okay? Drop that down to the positive x-axis. You have a right triangle. This is your y value on this side of the triangle. This is your x value over here. In this case, it'll be negative because there's your origin right there, right? This is negative direction of x. And then right here, this is what you're interested in. This is going to be your reference angle. Well, look, we went from 1 pi over 4, 2 pi over 4, 3 pi over 4. So this angle right here is another pi over 4 to get to that 4 pi over 4. That alpha in this case is pi over 4, the reference angle, right? There's 1/4 of a pi, 2/4 of a pi, 3/4 of a pi. What is that angle inside the triangle? Another pi over 4 to get you to this 4 pi over 4 here. Okay, so we've got one last one here. Let's move this over a little bit. Let's draw our circle again, my wobbly circle, sorry. Again, trying to draw it bigger. Here's your y, here's your x. So in this case, we have a negative 105, that's degrees, okay? So you always start here with 0. Remember, negative rotation goes in this direction. Positive goes in the counterclockwise direction, it's this way. So we're going to go backwards. We're going to go in the clockwise direction. This would be negative 90, right, from here to here. Backwards 90. This would be backwards 180. So it's somewhere here in this quadrant right here. Put it in green. Okay. Right, it went backwards 90 and then a little bit more. So this would be backwards 105 degrees, right? It didn't go back 180, it didn't go back 90, it went somewhere in between there in this quadrant. Okay, so there's your triangle again. You are in the third quadrant, right? If this is your origin, this over here is the third quadrant. Okay, so you're going to have a negative y and a negative x right here on your triangle. It's a right triangle. Here is your nice reference angle right there inside that triangle. That's your reference angle. So what is it? Negative 105 plus whatever that is gives you negative 180 there. So you don't have to think in terms of negative anymore. What is that angle in that triangle going to be? I believe it's going to be, I think it's going to be 75 degrees, right? Does 75 plus 105 equal 180? Yes, 75 degrees. Okay, so if we were doing trigonometry, we've got our triangle now, so it's going to look like this. This angle here is going to be 75 degrees. That's a right angle. And then you'll have some x, and there's the radius right there. X, y, and radius values right there. So now you can do all these ratios, and this is the angle that you're looking at right there. Okay, so look at where these reference angles all are. If you pay attention, every single reference angle is, let me draw it in there. It's closest, look, it's not down here at the edge of the circle. It is closest to the center of the circle there. It is closest to the center of the circle, that angle on the triangle that is closest to the center of the circle. Same with this one, closest to the center of the circle right there. That is your reference angle. So let's see if we have one more little piece that I will offer you up here. So this is where we're going. We are going to impose a circle on top of a coordinate system, your regular coordinate system. And here it is looking at this. Now all of your ratios can be done inside a circle with a radius. Okay, so you're going to have your reference, your reference angle, which is closest to the center of the circle there in the triangle. And you can do all your trig ratios based on that triangle. Opposite over hypotenuse, right? There's SOHCAHTOA there. SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So remember, it's always sine of an angle equals a ratio. Cosine of an angle equals a ratio of sides. Tangent of an angle equals ratio of sides. Okay, so we just named them conveniently, whatever that point is right there, right? This is the x coordinate is this piece, the y coordinate is that piece right there. That is where we are going. Thank you very much.